Professor Chandra Wickramasinghe is a professor and director of the Buckingham Center for Astrobiology at the University of Buckingham in the United Kingdom. He's an award-winning poet and the author and also the co-author of over 30 books and over 350 scientific papers in international renowned journals. In 1992, he was conferred by the President of Sri Lanka with a titular honor of the Vidya Brahma Vidya Jyoti. And so I'd like to invite him, Professor Wickramasinghe, to please make your presentation.
Thank you. Can you hear me now?
Yes, clearly, sir.
Okay, and can you see my slides as well?
Yes.
Okay. Okay, so this is essentially not quite a contradiction, but a different point of view from what you heard a couple of minutes ago from Professor Nick Lane of London University. He and I and lots of other colleagues of his would perhaps regard this as being not in the same vein as their kind of research, but I would argue that it is as important, perhaps more important than the attempts that have been made just to recreate the first tentative steps from non-biology to biology, which is what they're doing. I mean, that's one question that followed from the Nick Lane lecture is what is the nature of consciousness? And I profoundly disagree with his answer, and perhaps I agree more with your point of view. Anyway, be that as it may, so what I want to now do is to give you a sort of a broad, rapid overview of the really fast-growing evidence for panspermia as being the mode of origin of life in the universe. Okay, and this is a tale essentially of three books that carried predictions over a period of time from 1977 and through to 1982. These books are shown in the next slide that you can see. Life Cloud was the first book that Fred Hall and I wrote, and then Diseases from Space in 1979, and Evolution from Space in 1982. And everything that's happened since 1982 is essentially a confirmation of the stuff that we already had by the turn of the 1980s. So it is essentially also, I think I want to stress, this is Fred Hall, a picture of Fred Hall as a fairly middle-aged man. And this is a picture of me as quite a young man at the age of sort of barely in my late 30s. So this whole story is essentially a mixing of cultures and a mixing of ideas across continents, as I indicated in this signpost, Europe on one side and Asia on the other. So that's the general backdrop. And I want, if I can show this little video clip as an introduction, I would like to do that. Following the publication of our book, Life Cloud, in which we presented the first strong arguments for organic molecules being present in vast quantities in the space between stars, sorry, this is not showing, so I don't know if I can show this. It is a video clip that I thought I had set up to show, but it is not showing. So I will skip that then, and screen. Okay, yeah. Unfortunately, I can't show it. This is a couple of minute video clip. If possible, I shall recover it at the end of my talk and show it. Anyway, to go on with the rest of my talk, in the first lecture yesterday, I discussed the long history of ideas leading up to the orthodox, culturally sanctioned point of view that I think your previous speaker expounded with great eloquence. This is the theory of an earthbound primordial soup, and it could be in the hydrothermal vents, as he was talking about. It could be anywhere in the oceans and so on. And that's the idea. That's a sort of broad sweep of ideas that I began to challenge in 1976 with the late Sir Fred Hall. We saw in the last talk that the Earth-centered theory of life in a general philosophical sense is in serious conflict with ancient ideas. And more significantly, it's in conflict with all the relevant data that is really available from the broad sweep of biological information that we have, not just sort of simple chemistry as we were hearing recently, but from the broad sweep of chemistry, from chemistry of cells to epidemiology and so forth, particularly those regarding or relating to the absolute complexity of life at the molecular level. And this is really something that I want to stress. Life at any level, the simplest bacterium, the simplest virus, is incredibly complex. And to think that it just happens by flukes of chemistry and flukes of physics and in a small vent is, I think, a bit, I don't know how to describe it. Anyway, extending life to be a cosmic phenomenon, as I said last time, has distinct precedents in the Vedas, in Buddhism, in Chinese and Egyptian civilizations, way ahead of the Greco-Roman civilization that we are accustomed to at the present time in Europe and throughout the world. If you go back to 500 BC, I referred to this already last time, the Greek pre-Socratic philosopher Anaxagoras posited that seeds of life are everywhere. And he, I think in terms of the Western culture, he is the first person to introduce the general concept of panspermia. Then around 400 BC, 100 years later, again a Greek, Metrodorus of Chios, said, sort of accepting Anaxagoras, accepting panspermia, said, and I quote, "It is unnatural in a large field to have only one shaft of wheat, and in an infinite universe, only one living world." That's a very profound statement. And then go forward another 350 years to circa 50 BCE, the Roman poet Lucretius, poet and philosopher and in many ways a scientist, said as follows: "Nothing in the universe is alone and unique. And therefore, in other regions, there must be other beings, other earths inhabited by different tribes of men and breeds of beasts." Okay, so this is the story, and I think I already mentioned last time that if you go forward to 1600 BC, you have the whole idea of the primordial soup sanctioned by the Roman Catholic Church, and inquisitions follow. Galileo is tried. Giordano Bruno in 1600 is essentially murdered for saying that there are an infinite number of planets and life around them. So this is, but much as this was pure guesswork and speculation in the early days when Bruno and so on and Metrodorus and Anaxagoras were pronouncing these things, we know better now. The only planets that were known in the old days was, of course, the Earth. And now we know that there are many planets revolving around the sun, as I've shown in this sketch. It's all very familiar to you guys. There's a comet streaming, going through the planetary orbits and so on. So that's in the past 4 decades, space exploration has expanded our horizons vastly. And the search for alien planets has really become a very serious activity, yielding rich rewards. And as your previous speaker said, the present activities in NASA and so on, using the Kepler satellite, searching for exoplanets, was launched in 2009, I think. And already in just barely a decade and a bit, we have Kepler mission yielding a total estimate of Earth-like planets on the order of 140 billion. This is almost one for every sun-like star in our galaxy. And it is also reckoned with very good argument nowadays that a good fraction of these could be life-friendly, could be habitable, could be in what is called the uh, Goldilocks zones of these planetary systems. So let's turn to the specifics of life and regard this has been the most important thing that we have to discuss today. In 2021, the present day, the only definite evidence, 100% definite evidence that we have and we accept for life anywhere in the cosmos is, of course, on this green planet of ours, on the Earth. And the most important question that needs to be answered, of course, how did life get started here on the Earth in the first place, right? How did so-called abiogenesis work on this really insignificant dot in the universe? This question has been pondered by our ancient cave-dwelling ancestors, as I told you last time, pondered by theologians, philosophers from time immemorial. And we saw that in the last lecture that the long-held theory of primordial soup could be argued as being seriously flawed and at the very least seriously deficient in terms of explaining our phenomenon of life, the life that we all enjoy here on our planet. That is largely dependent on the molecular complexity of life, which I think I already told you is what I would describe as super astronomical. Astronomical means numbers involving numbers that are sort of count the number of atoms in the observable universe. These are small numbers compared to the molecular complexity of even the very simplest living system. For the simplest living system, which is a bacterium that we think of nowadays, well, the virus is also a semi-living entity, and I want to include that here. The simplest bacterium is called Mycoplasma genitalium, and the probability is 5,000 enzymes, and these enzymes are, of course, crucial for everything that the microorganism has to do, like tapping energy from the environment, replicating, and so on. The chance of these 5,000 enzymes being assembled from a primordial soup of all the relevant amino acids can be estimated. It's a simple calculation that an A-level math student can do, right? And it is really horrendously improbable. It's something like 10 to the minus, I reckon, a couple of thousand. And in this analogy that I've shown here, a blind man or blindfolded man trying to say not one blindfolded man, say 5,000 blindfolded people having what is was very common in the days of my grown-up children, now called the Rubik cube, right? So you have 500 Rubik cubes randomly sort of turned around, and you give this to these guys and ask them to, in one move, one twist, to unscramble all the Rubik cubes. And in a single move, this probability is greater, is a bigger probability than the origin of the simplest living system, which is Mycoplasma genitalium. So that's the kind of horrendous improbability that we have to face. Inescapable conclusions are that life is either miraculous, it's a miracle that happened on the earth, and against impossible, incredible odds, as I just mentioned. And if that is so, it will never happen again. It will never be repeated anywhere. And if that's the case, then all these programs of SETI and so on are doomed. We are hopelessly alone as living creatures in the cosmos. The alternative that I and my colleagues, and starting with Fred Hoyle, have propounded is that fully fledged genes carrying all the information of life in the form of bacteria and viruses are everywhere in the cosmos. And as the physicist Helmholtz declared in the year 1877 or something, I think I told you last time, they develop wherever, these seeds develop wherever they fall on fertile soil. And wherever means, of course, wherever in the universe, not just on the Earth. So this is the lead up that we had in 1981 to the theory of cometary panspermia. It is different from the old panspermia. It is more specific based on the growing evidence that we saw already in 1981. And it asserts and provides evidence that life is indeed a cosmic phenomenon, that genetic components of life are everywhere in the universe, transported to the Earth by comets, and similarly transported to other planets in our solar system and in other stellar systems also by comets. So that's the broad outline of the cometary hypothesis. And the ultimate origin of life is what everyone asks, and this picture is really a sort of graphic description of the universe going all the way to a postulated Big Bang. The ultimate origin of life from non-life remains outside the remit of panspermia. It probably remains outside the remit of explorable science as well. That's what I personally feel. It is connected with the origin of the universe, and just as matter itself, it is essentially intractable. And this is essentially the point of view that is espoused by all the ancient philosophies that include the Vedas. So let me now just briefly go through the broad script of panspermia and life on the Earth. If you look at the Earth, our planet, a green, lush planet that you see in this picture, it is full of life, it teems with life. But this was not always the case. Life was not always here on our planet. And if you go back to some 4.5 billion years ago, the Earth was not even formed, right? It was in a state of formation, coalescence from a disk of material expanding all the way to perhaps the orbits of the comets now in the present day solar system. And so this was rotating, and it is from this rotating disk of material that the Earth eventually formed, and the Sun eventually formed in the center. 400 million years later, that is about 4.5 billion years ago, the Earth was already formed in the last stages of its formation. And at that time, if you were sitting on the Earth, you wouldn't have been very happy. A brisk rain of hot, rocky asteroids would really fall on your heads. And this is this rain of rocky asteroids that formed the crust and the surface of the Earth. And watery comets were also coming in. It is the watery comets that brought the Earth's first oceans, and evaporation of water from the oceans gave rise to the Earth's primitive atmosphere. However, even after the Earth was fully formed, its surface for quite a while was far too hot, was far, far too hot for even organic molecules, let alone for life, for even organic molecules to persist. We know now that between the years 4.5 and 4 billion years ago, this planet was being showered by comets, mainly by comets. And as I said a moment ago, it's these comets that brought water that went to form the Earth's first oceans. This is a recent discovery, recent in the sense that it's only 6 years old. In 2015, it was discovered that the very, very first evidence of any life, any microbial life on the Earth, is to be found today, locked away inside crystals of zirconium, precious metal, that condensed about 4.5 billion years ago. And these rocks are now exposed quite high up on the surface in the Jack Hills outcrop in Western Australia. And so scientists have gone and excavated this region, collected these rocks, have taken the bits of zirconium out from the interior of the rocks. And inside of those crystals, zirconium crystals, you find the dead bacteria in the form of graphite carbon blobs. And how do we know that they're bacteria? Well, we know that they're bacteria because they have a carbon isotope signature, an excess of carbon 12 over carbon 13, And that is a clear indication that these little micron-sized blobs are the first bacteria that arrived on the earth at the very, very first moment that any life can survive. So I don't know how they can talk about a primordial soup. There was no primordial soup possible under these conditions. So this puts the beginning of life on Earth to a time when the Earth, as I said, was in the midst of fierce impacts, fierce collisions with comets, strongly supporting the thesis that it was comets that brought the first life to Earth some 4.1 billion years ago. And that really is the strongest first evidence for empirical evidence for cometary panspermia. So let me next briefly, I've gone through this in other places, briefly touch on the evidence from cosmic dust, from interstellar dust, which was essentially my PhD thesis when I arrived in Cambridge, England, to work with Fred Hoyle in the 1960s. So from 1977 onwards, the astronomical evidence was growing at a rapid rate, and measurements of stars, stellar observations, interstellar observations, combined with our calculations, showed that cosmic dust should be made, or must be made, of the stuff that matched the properties of bacteria, uncannily matched the properties of bacteria. And these were the two books that I published, the Interstellar Grains, the first ever technical book ever written on interstellar dust, was published by me, single author in 1967. And then, as I mentioned earlier, Life Cloud explored the origins of and the implications of that in 1976 with Fred Hoyle. So this was the story that began to unfold very, very rapidly. In 1982, I had the involvement of my brother, who was then a professor at the University of the Australian National University in Canberra. He had access to the most powerful telescope in the world at the time, which was the Anglo-Australian telescope. And we urged him and his colleague, David Allen, to try to test the theory of panspermia, test the possibility that the whole of all this dust cloud that you see in between the Milky Way, that these were really dead bacteria, carbonized partially bacteria. And we made a really definite prediction. And months later, when the observations were made, this is the kind of correspondence we had. The points are the observations of the astronomical source, which is a very distant source of infrared light in the center of the galaxy, traversing all the dust clouds in space and so on, and showing a fingerprint that is unequivocally corresponds unequivocally to the bacterial spectrum that was obtained earlier. So this is the first correspondence of this kind, right? A prediction followed by an observation and followed by a correspondence. Now that was not the first. We had a whole succession of these, of similar correspondences, spanning the period from 1981 to almost the present day. And if you are dealing with normal people, with rational people, with people who support the old sort of Karl Popper's ideas of falsification of scientific hypotheses, you would jump up for joy and say, this is a theory that has been verified up to a point that can never be refuted. But as I said in my first talk, culture intervenes, cultural reasons intervene, and that has not happened yet. But let me go on. There were many other correspondences. This is another, I don't want to labor too much on the correspondences. There's a prediction and an observation, and now in the ultraviolet. The dull stuff was in the infrared, now it's in the ultraviolet. And the evidence just went on and on, supporting interstellar material being related to bacteria. So evidence in the present year, 2021, for biologically relevant molecules everywhere in the cosmos is just absolutely irrefutable. So these are genetic building blocks of life ready for assembly, like the bits and pieces of a child's jigsaw puzzle. They need to be put together. assembled on any habitable planet. So this is the picture of kids building blocks being assembled, a complex pattern assembled, and these could be assembled into multitudinous forms depicting the very varied arrangements of the life that we see here on our planet. So that's evidence from the interstellar medium or from space. Let's briefly touch evidence from comets, because comets are very much in the news now. Cometary panspermia requires that comets are both the distributors of life and the amplifiers of life. So comets have a long-term property of having warm, watery interiors, radioactive heat sources providing the melting of ices and so on. And so this is the evidence that started emerging from 1986. Again, a prediction of the infrared properties of dust was made for the first time, of cometary dust was made for the first time. And the correspondence with the bacterium spectrum, the curve that you see here, is so precisely reproduced. So that's number two in terms of astronomy, that second of the predictions. In fast forward to the sort of 5 years ago, European Space Agency's Rosetta mission went to the comet 67P CG and landed in 2014, also produced tantalizing evidence of life, of biology, but it's, and I don't need to say this, the data is being either distorted or being cautiously, overcautiously interpreted by a vast body of orthodox scientists. Most recent studies from this mission shows that there are tantalizing signs of water below the crust of the ice on the surface of comet, the Rosetta mission comet. That the ice occasionally ruptures due to high pressure, and you can see sort of fountains of gas coming out of it, laden with dust and I think with also bacteria. And these are not really much talked about. The spectral data, again, these are curves that are shown here, match the reflectance properties of a bacterial material. The infrared spectrum between 3 and 5 microns matches precisely. The comet exuding methane and exceedingly complex organics, exuding oxygen. So there's a combination of methane and oxygen, which is, in terms of non-biology, just almost impossible. One is oxidizing, one is reducing. You should not have that. So it is again an indication of biology. It has a very dark surface, this comet, surface reflectivity that matches desiccated bacteria and viruses. So that's what we have here. Very recently, in this present year, a few months ago, there were many surprising discoveries that was made by the spacecraft called OSIRIS-REx that reached an asteroid, a very, very peculiar, mysterious asteroid called Bennu. It reached the asteroid in 2018, found a huge number of surprises. People didn't expect this. It was carbonaceous. It was very much like a meteorite that fell in Sri Lanka in the year 2013, extremely porous, had heat-producing radioactive elements, and it was once certainly filled with water, and I think unquestionably with the legacy of cosmic life. So this is only a few months ago, this data. There is a bit of it being brought back to Earth 3 years from now, and who knows what would transpire. Earlier in October 2018, a group of French astronomers, radio astronomers, reported the discovery of a profuse flux of ethyl alcohol and a sugar in the tail of a comet called Lovejoy, a very appropriate name for a comet that is essentially spewing out the equivalent of 500 bottles of the best red wine per second, clearly the products of fermentation. No one has mentioned fermentation, but they mentioned the alcohol spewing out. And so there is a conspiracy of silence. Sorry to say that because I hate conspiracy theories in general. So there's no question that the comets like that, comets and asteroids like Bennu that we talked about recently, are the carriers of life at the present time. And let me just, in the remainder of my talk about the further implications of this conclusion that comets carry uh, bacteria and possibly viruses. Are bacteria and viruses from comets coming into the Earth today? That's an important question. It's a question that concerns all of us because it could have effects on present day living forms. If comets brought life, as I told you now a little earlier, 4.1 billion years ago for the first time to the Earth, that process could not have stopped. It must continue because the Earth orbits crosses the orbits of all of these Bennu-like asteroids, the comets, and so on, and debris from these objects enter the Earth's atmosphere every single day. You get vast amounts of debris. People don't talk much about debris, but if you look at the dust on your mantelpiece, anywhere on the surface of the Earth, a significant fraction of that dust is from this universe, from outside the Earth. In collaboration with the Indian Space Research Organization in 2001, a group of us in the UK collaborated to essentially collect material from the stratosphere and to test for the presence of microorganisms at some height, like 41 kilometers in the Earth's stratosphere. On the 20th of January, which incidentally is my birthday, of the year 2001, the seals of these canisters that were flown were opened on remote command. And when the valve, this is the canister shown on the right, and when the canister's valve, a vacuum is released, is opened, air from the stratosphere rushes in, as you can see that, with all the bits and pieces in it, all the bacteria, little white blobs, everything goes into the canister. Then it cools, it freezes, and the cylinder and its frozen contents are parachuted back to the Earth to be examined in the laboratory. And so what we did then was to look at this air at 41 kilometers, both in India. It was done in several institutions in India, very famous institutions in India were involved in this, and in the UK. And we found that it contained an abundance of bacteria that could not have come from the ground. This picture here is of a clump of putative bacteria and a rod-shaped bacterium. And there was also viable, culturable microorganisms indicated by the use of fluorescent dyes. So from the sampling of the stratosphere that's been done then and later in subsequent experiments, the known falling and also the known falling speed of particles of the sizes of bacteria, right? We know how fast a certain particle size falls through 41 kilometers. We know how much we collected in a sort of measured volume of the air. From that, we can estimate the total bacterial or viral material that falls through the atmosphere every single day. And that we estimated to be 20 to 200 million bacteria per every square meter per day, every single day. And this is a flux that should normally not go unnoticed, and we should not ignore it. But it's very, very strange that people really don't talk much about it. Recently, about a year ago, there was a group of international scientists that went to the top of the Nevada Hills mountain range and actually recovered viruses and bacteria about the same rate falling from the skies. And they assumed, of course, that most of it is recycled from the ground. But in the case of the stratospheric stuff, it cannot be recycled because 41 kilometers is too high for lifting normally from the ground. So most compelling evidence, of course, came only a couple of years ago, the announcement of microbes discovered on the surface of the International Space Station at 400 kilometers height. And this is a height that can in no way be considered to be contaminated from the ground. So the windows of the ISS was swabbed 6 times between 2010 and 2016, and many microbes were discovered. And since I'm running out of time, am I running out of time or am I okay?
You've got about 5 minutes, Prof.
Okay. Okay, I'll quickly wind up then. So this is the ISS data that shows that microbes are coming in, and then very quickly go through the implications of cosmic microbes coming in for evolution. And this we argued already that viruses and evolution are intertwined. Viruses must have an effect in continuing to evolve life on the Earth. We require cosmic viruses to be inserted into our genes in this way. Original species, one species taking on the yellow line is a virus addition, and so on. So it goes on like this. Darwinian natural selection, of course, acts, but only as a fine tuning. And then every new development in the fossil record is due to viruses from space. We have the first appearance of virus of life that we told you was 4.1 billion years, and then discrete times we have other things happening. And evolution is seen to occur not continuously, but in significant jumps, as has been recorded in the rocks. So Homo sapiens appears relatively recently, right on the top, as you can see. And there's an extinction event, a Cretaceous Tertian extinction event, so on. And so this is, let me skip that also. The Cambrian explosion of life took place about 500 million years ago, led to the sudden emergence of lots of very interesting creatures that did not, and life forms that did not exist before. Okay, Human Genome Project. I think I have to talk briefly on that. In 2000, about that 2001, the Human Genome Project was completed, and the sequencing showed that over 5% of the human genome is made up of viral sequences with herbs and signs, and you see that in that chart there. So DNA is found to be essentially to carry the history of past pandemics. And the viral pandemic, leaves a relic of the virus in the form of an nerve in the gene, and that is the nerve that is being detected. And the whole tree of hominid evolution then branches at points where the viruses have been inserted, and you can see those arrows there. So it's a very interesting story that is intimately connected with viral invasions, as I have argued for a long time. So do I have 5 minutes to talk about pandemics, or should I?
Yes, about 4-5 minutes. Yeah, sure.
Okay. So let me just close with this story of the implication of pandemics. So there are two paths for an incoming virus to take once it gets to a planet with life like humans and so on. The pathogenic microbe injected from comets falls to the ground. It could either have no stable reservoir among plants and animals on the earth. It could just fall with the falling viruses and bacteria. But it can also drive epidemics from outside, directly from space, or it can form a reservoir, like in smallpox, and then creature to creature, person to person transmission is the main source of transmission. Throughout history, plagues have come and gone, and they could be either global or local. Plague of Athens broke out in the year 430, and so forth. Let me skip because I'm running out of time. Plague of Justinian. So the whole history of our civilization has been punctuated by a series of plagues. So finally, in the last few minutes, the question is, could influenza, which concerns us very much from time to time, and could this really menace of COVID that we are all living with, and you in India particularly are suffering from, could that have originated in space? And I think the answer is yes. Person-to-person spread is essentially happening, of course, but the question is it the main mode of conveyance of the virus? Is the main mode of propagation? And I think the answer is no. The if you go back, turn the clock back, and and it is really I've stopped sharing. So I think the you have essentially your screen sharing, it says, but can you hear me?
We can see your screen, sir, and we can hear you clearly.
Oh, okay, okay, I don't know. Okay, is it still okay for me to go on for a couple of minutes, or you want me to close now?
A couple of minutes, is that okay? Because we still
Okay.
have 1 minute.
Okay. And anyway, I think it's almost the end because I planned only to end sort of briefly on the. So influenza is a case where there's strong evidence has been accumulating for non-person-to-person spread being a really major mode of transmission of the virus. And 30 years on, and I'll skip that as well, but they come back to, we'll skip all that, I suppose, unfortunately. So ongoing incidents in October 2019, large viral load, I think, of SARS-CoV-2 virions came somehow from the skies into the stratosphere, into the environs of Wuhan in the Hubei province of China, from an external cosmic cometary source. It is probably related, it was probably related, and it's not definite yet and no definite knowledge, related to the Jilin fireball that was recorded and seen by very many people on a certain midnight in October 2019 over northern China. The cloud of virus is posited to have first entered the northern tropospheric jet stream, carried around the world in the wind system in the northern hemisphere first. And this map here with the red band and dark red referring to stronger incidence is the case intensity of the COVID-19 up to May 2020. So it is a year old, and it is confined to the 40 to 60 degree latitude belt. Thereafter, the global wind systems that essentially cross latitudes and so on, takes the virus all over the world. And you can see at the present time, it is all over. India is particularly badly affected, South America particularly badly affected. So it is carried in these wind systems that you can see in the background of the slide, global tropospheric wind systems. And then it descends on various locations, frequent occurrence of mystic places, mystic clusters of COVID-19 has been recorded very frequently in Australia, and with no recorded contact connection. They've got very efficient contact tracing and so on. And in these dark regions that you see on that map, there are cases that emerged almost simultaneously with no intervening connections. So infall events from the stratosphere of this virion cloud still seems to continue. Hopefully it's going to end soon. Also, I should not stop without referring to several instances of ships at sea being affected after all of the passengers, all of the crew being initially tested negative for COVID. This has happened many times and gives evidence for sporadic infalls from the sky. Same thing happened in case of influenza in 1919, 1918, 1919. So that's the story. Summary of the process for influenza and COVID is that cometary virus comes into the stratosphere, winter download, downdraft transported in the troposphere, raindrops and so on, ground level, mists and human person-to-person spread follows from there. So that's the end of the story. The recognition that alien viruses are a present threat, of course, is very important. We have to recognize that, and that really necessitates regular surveillance of the stratosphere, which should, I think, be accorded highest priority in the future. In 2020, the Earth-centered theory is really looking very thin in terms of facts, but the bandwagon continues to go. But I think the bandwagon that is supporting the standard theory is very close to falling over the cliff. So that's where I would like to end. Thank you.
Thank you so much, Professor Chandra Wickramasinghe, for the interesting presentation. I'd like now to call upon the audience to present your questions. Can you please raise your hand? I think first up, I'd like to call Subhash Chandra Singh to ask your question to Professor Wickramasinghe. Can you please unmute yourself? Can we have the screen unshared? Subhash Chandra? Okay, maybe can we have Saumya?
Hello, am I audible?
Yes, you are.
Okay. Thank you, Professor. It was an intriguing idea from your part that the arrival of viruses and microorganisms from space, the panspermia theory. So I am Shomudi from ISA Kolkata, a biology major student. So during the onset of pandemic of the COVID in 2020, so we had found a post that it was retweeted so much that it caught our eye that these pandemics come in a cycle of 100 years, say 1820, then 1920, and now 2020. So could it be related to a celestial object that comes in the vicinity of our Earth in a 100-year cycle, and thus if viruses and other stuffs from the celestial object are attracted via gravitational pull?
Yeah, I think that is a real possibility. Even more suggestive of this period, I think the more I think I wouldn't rule out the possibility of the Earth going through a cloud of infective particles with certain periods like 100 years or something else maybe. But if you look at the sunspot cycle, the sunspot cycle has also many periods, right? And in this present COVID crisis, we had the lowest sunspot activity in, I think, 150 years. A very, very low sunspot minimum was recorded in 2019, 2018. So that's also another consideration, because when you have a very low sunspot cycle, the magnetic protection that the Earth has to prevent charged virus particles, charged bacterial particles from comets getting into the Earth, that protection is removed. Magnetic field provides a protection, kind of shield against, to some extent, against the incoming bacteria and viruses. So it could be the period, as you said, comets have periodicities. 100 year is a possible period of a comet carrying a particularly infectious cargo. On top of that, you also have the sun acting as a sort of producing effects that provide barriers for viruses and bacteria entering our planet. So it could be a combination of the two.
Okay. Yeah. Thank you, Professor. This is an interesting topic. I could go and read further on the sunspot, the magnetic waves, and the viral outbreaks. Yeah. Thank you, Professor.
Okay.
Thank you. Can we have Diptesh to unmute yourself? Diptesh?
Hello, am I audible?
Yes, you are. Go ahead.
Congratulations, Professor, for the very informative lectures of yours. I would like to have your thoughts on one of my doubts regarding your lecture. I have a serious doubt that life on Earth might have started because of panspermia, but life, particularly life, it might have started because of abiogenesis somewhere, and it got transported to Earth. Just because we do not have other planets around us that have a habitable zone like Earth, it did not propagate in that way where it did in Earth?
Well, I think the answer to the question is that abiogenesis, if you if you want to explain the origin of life from non-life, if the universe at one point was completely free of life, right, completely inorganic or non-biological, then you've got to have a place where that transformation takes place from non-biological universe to a biological universe. My doubts about it happening on the Earth is that the Earth is a really, really minuscule, insignificant bit of the universe, right? You can forget about the size of it's trivial, and you need to go to bigger and bigger and bigger and bigger volumes of space and time in order to overcome the improbability of abiogenesis yielding the result that we are looking for. I mean, abiogenesis as a logical system is fine, right? If you start with non-living material, we've got somehow to make living material from non-living material. But to do that, you need a resource of information. You need a probabilistic space that is far in excess of anything that could be available on the Earth. I mean, I've written extensively on this, and I think some people take note of it, so other people ignore it because it's too uncomfortable. If you accept this argument, then all of the stuff that is being done in laboratories around the world might seem as though it is a waste of time. I don't personally see it as a waste of time because I think any scientific experimentation, like the experiments of in various labs of abiogenesis, these experiments are yielding really deep insights into how life functions. But in order to answer the biggest question, I think you've got to go to the biggest available system, and the biggest available system is the universe as a whole. That would be my answer.
Thank you. Thank you.
Can we have Doma Dala promote to unmute yourself, please?
Thank you, Professor, for your excellent talk. I am Dr. Pramod from Hyderabad. I have two questions and briefly will ask you. Am I audible to you, sir?
Yes, I can hear you.
Yeah, I agree with you. I am working on the COVID-19 pandemic. I agree with you that periodicity of pandemic is occurring every 100 years. It was in 1720, 1820, and 1920 to 20. And it may be true that as the sunspot variation occurs for every 11-year cycle, it may be 100-year cycle also.
There is a
rhythm is there. So I was working ionospheric physics. The sunspot varies every 11-year cycle. And it may also be 100-year centuries variation may be there.
I think you're right. I mean, the variations that have been measured are just the visible sunspots, right?
Yes.
You just counted the sunspot. There could be effects on the sun that we haven't studied carefully enough, and they could have different periodicities. Yes, certainly.
So another question is that, do you feel that people say that it's originated from China, but not affected in China? Because of the wind direction, it has gone to other parts of the world?
I think that is true. I mean, the desert, the terrain of the country is very, very important. If you have also, I think if you have any virions or bacteria coming from the stratosphere, and I think I told you already that the evidence for sort of 100 million particles of viruses and bacteria falling per square meter per day is really staggering.
It's a huge number.
Pardon? Huge number. And it is not fiction, it is fact. It's been verified not just in the Indian experiment of 2001, it's been in the Rech et al., the whole group of international scientists who went to the top of the Nevada hills 2 years ago. They made the same got the same number. So it's a huge number. So there is this huge number of viruses that are coming in. And the question is, where do they come from? Are they all recycled from the ground, which is what the sort of standard biologists would like to think? Or is there even a minute component of that input that is...
It might matter. Another question is that I am working with some other people. It is because of the rate of killing of animals is very high in the world now. we are killing nearly 30 millions of animals per second.
Hmm.
That huge number, is it a curse or maybe curse affecting on the human beings?
I agree.
Because, 30 millions per second is a huge number.
Yeah.
We are killing the animals. Only animals I'm talking about. So much research is going on the animals and the creatures and everything. And in fact, animals are more powerful than humans. Because we cannot fight with the animals at all unless we go with weapons. So they may be attacking this, which I don't know. We have to work on this.
Well, I think the animal origin of the virus, of this COVID virus, is very poorly supported in terms of evidence. And I know that is a very fashionable theory now, that the COVID-19 virus came from a bat and then through to a pangolin and then to a human. But if you work out the probability, my colleague who is a geneticist in Australia, he's worked out the probability. It's just incredible. It's 1 in 300, 1 in 10 raised to the 300 or something. So you just can forget about it. There's no chance that it was a two-stage mutation jump from a bat to a pangolin to a human. Then if you reject that just for the COVID virus, if you reject that, then they could go into the idea that it was an artificially synthesized virus, which I think is equally stupid. But coming back to your point of killing animals, I deplore it myself. I think that there's far too much of futile killing of animals. I think killing animals, in any case, as a Buddhist, I disapprove of. And I'm sure that there's a...
And I realize that in UK, the veganism is also increasing.
We can move forward.
We need to get someone else to ask questions. Sorry, thank you for your questions, Dr.
Thank you.
Can we have Johan Nikhil to please ask your unmute yourself?
I just wanted to ask, thank you for your talk, Professor. I wanted to ask about the idea that the COVID virus came from space. But isn't it known that the COVID virus has already been in the Earth for a long time, and also that if it really came from space, wouldn't there be more cases of random isolated cases occurring? Why did it start from China and then slowly move into the world as people started moving out? Because even the case which you mentioned about in a ship where there were negative cases at first and then people became positive, we know that it's possible for tests to be wrong, that COVID tests aren't 100% accurate. And shouldn't there be more cases like that?
Well, I agree. I think that you can always question that data, but I think there's too much of that kind of data. And we have been publishing, we've got a paper in press. The Australian data is very, very interesting because unlike in India, which is a large number of people, there are too many people to try to analyze the statistics in India at the moment. But in Australia, the case numbers are very, very small altogether. And there have been very stringent lockdowns enforced from time to time, or from almost continuously for the last year. And in spite of all that, there have been cases that have been these that the map that I showed you with those grey spots. They've been mystifying the epidemiologists in Australia because they've been really trying to locate people from India coming there, people from China coming and starting it, and they haven't been successful. So I think similar to all the previous pandemics, like in the pandemic of the 1918-1919 influenza pandemic, I mean, person-to-person infection is certainly very, very important and is happening. But on top of that, there are injections that are de novo from outside of the system, and that's what I think is an indication of a continuing space incidence. But more has to be done. I mean, this is a hypothesis, a theory, and I think there's backup evidence. But if you ignore it, and if you ignore that possibility, then I think you're in serious risk of facing similar problems in the future and without really having a solution.
Professor, there's one question that came in the chat by Chandra Pushparatnam. He asks, do you think that the comet Oumuamua came from outside our solar system?
Yeah, I think the evidence that it came from outside of the solar system is absolutely 100% certain. There's no question about it. It's an exosolar comet. It's from a planetary system that is very distant from the Earth, maybe tens of millions of light years away. It's in it's in a hyperbolic orbit, right? So it came up. There's no question that it came from outside of the solar system, and it's returning to outside of the solar system.
Okay, we've got time for just one last question. Dr. Jayanti Chavan, can you just unmute yourself? We've got 2 minutes for the last question.
Am I audible?
Yes.
Yeah.
Thank you, sir, for the lecture. Sir, your question on evolution, you had said that evolution is seen to not occur continuously, but in significant jumps as per the records in the rocks. But how far can we corroborate this from observable phenomena like from first life to Homo sapiens? Are they really happening even now? Because we do have microbes, we do have, and we have all the life simultaneously.
Oh yeah, evolution is happening all the time. That's no question about it. But the sudden, discrete jumps, right? The introduction of new body plans that didn't exist before, and so on. They come in discrete, as step functions. There's absolutely no question about that. I think if you look at the record of the rocks, record in the rocks, you have unicellular life for maybe several billion years.
From unicellular life, it goes to multicellular way. Now it happens the same way. Is it that simultaneously species are existing, or is it that species are evolving as per Darwinian paradigm?
The Darwinian paradigm operating for what a couple of billion years did not do anything to produce from single cell to multi-celled life, or from prokaryotes to eukaryotes, right? So all of these sudden steps occur from outside of the biological evolving system. I think Darwinian evolution takes place, but it's a fine tuning that is involved in the Darwinian evolution. Occasionally, at random points in the time sequence, you seem to have introductions of vast quantities of new genes. That would be my interpretation.
Thank you so much, Professor Chandra. Can we just put our hands together for Professor Chandra Wickramasinghe for his presentation and Q&A?